Hey, Dave Stallman here, and I'm going to make a little video for geometry about how the ratios of perimeters and areas for similar figures are related to each other. So what I want you to notice on this sheet are, I got a couple tables at the top of the page that we're going to fill out, and down here I have a series of 4 rectangles that are similar, which means that the ratios of their sides are all the same. For example, this silver has side 3, the blue has side 6, the yellow has side 9, and the purple has size 12. And you can get from the first to the second by times 2, then first to third by times 3, and then times 4. Now, to be similar, the other sides have to match as well. So the silver vertical is 4, the silver blue is 8, the blue is 8, the vertical yellow is 12, and the vertical purple is 16. And so 4 times 2, 4 times 3, 4 times 4, 3 times 2, 3, 4. So they're all in the right ratios. Okay, it means they're similar. So let's fill out this table. For the silver triangle, what is the perimeter? Well, let's see, 3 and 4 and 3 and 4 has perimeter 14. The blue is 6 plus 8 plus 6 plus 8, and that comes out 28. The yellow is 9 plus 12 plus 9 plus 12. That comes out 42. And then purple is 12, 16, 12, 16, and that comes out 56. All right, so those are the perimeters. Let's do the areas. The area of the silver will be 3 times 4, which is 12. The blue will be 6 times 8, which is 48. The yellow will be 9 times 12, which is 108. And the purple will be 12 times 16, which is 192. All right, let's do a little comparison here. So let's compare rectangle 1, which is the blue, to the original, which is silver. The sides would be, I'm going to use the horizontal sides, 6 over 3, which is 2. The number 2, or the yellow, to the original would be 9 over 3, which is 3. The purple would be 12 to 3, which is 4. So we can see that the ratios of the triangles are 2, 3, and 4. Now let's look at the perimeters. If we look at the perimeter of number 1, which is 28, to the original, which is 14, we get a ratio of 2. If we do the yellow to the original, the yellow is 42 to 14, which if you divide it out is 3. And if you compare the perimeter of the purple to the original, you divide that out, you'll get 4. So what I want you to notice is that the side ratio perimeters, ratios, or the side, take 2. The side ratios, 2, 3, 4, are the same as the perimeter ratios, 2, 3, 4. Now let's look at the areas. If we compare number 1, area 48, to the original area, that's 48 divided by 12, that's 4. If we compare the yellow, the area is 108 compared to the 12. And if you divide that out, you'll get 9. And if you compare the area of the purple to the original, you'll get 16. Now, this is kind of interesting. What do you notice? If you look at the side ratios compared to the area ratios, they are not the same. In fact, what's the relationship? Well, if you take the side ratio squared, you'll get the area. Side ratio squared, you get the area ratio. Side ratio squared, you get the area ratio. So here's the summary. If the similarity ratio of two similar figures is A over B, then the ratio of their perimeters is also A over B, but the ratio of their areas is A squared over B squared. All right, so what does that mean? Let's do an example. Say that we have two similar figures. These happen to be trapezoids. And this one has a side of 6, and this one has a side of 9. Well, here's what we know. We know that the side ratio is 6 to 9, which means that the perimeter ratio is going to be the same, 6 to 9, but the area ratio is going to be 6 squared over 9 squared. So this would be 36 over 81. So that's how these ratios work. Now, let's say that we have two similar pentagons. One is bigger than the other. Okay, this one has side 4. This one has side 10. And we know that the ratios, or that they're similar. So the side ratios would be 4 over 10. Now, if this one has area 27.5, what's that area? All right, well, the small one has area 27.5, and you'll notice that I put that with the small side. Those go together. And then the area for the big one is unknown. So how do we figure this out? Well, we know that if you take the side ratios and you square them, then that's the same as the area ratios. And so now you can solve this proportion. So we would have 4 squared is 16 times A, 10 squared is 100 times 27.5, and we can divide by 16. And let's see, what do we get? 100 times 27.5 divided by 16 is 171.875 centimeters squared. All right, let's do one more example, then we'll call it quits. Let's say that we have two triangles and they are similar. This one has area of 50 centimeters squared, and the bigger one has area 98 centimeters squared. Now, what is the ratio of the triangle sides and the triangle perimeters? All right, we know that 50 divided by 98 is the area ratio, which is essentially a squared over b squared. And so if we want to solve for the actual side ratio or the perimeter ratio, we just have to take the square root of both sides. Okay? So let's do that. A over b. Let's see. Let's do the square root of 50 divided by the square root of 98. And we get 0.71. And so now I'm going to do this. I'm going to go math, fraction, and it's the same as 5/7. Okay, so that's the ratio of the perimeters or the sides. Now, just for fun, I want to show you something else. These two numbers are both even, so we could simplify this. What's 50 divided by 2? Well, it's 25. And what's 98 divided by 2? Well, it's 49. And if you took the square root, you'd get 5/7. So that's actually a faster way to do it. But they both work the same. We know that's the ratio of the areas, and that's the ratio of the sides. All right, there we go.